Right, hello everyone. As Liz said, I'm Jo Tidmarsh. I'm based in Oxford in the UK, so I apologise for the English accent and any local references that I may accidentally put in. I have been with Earthsoft for 8 or so years, and in a previous life I was a hydrogeologist, and hence I've been given the lovely job of presenting and talking to you about geochemical plots. So on our agenda, I've introduced myself. I'm going to go a brief review of the plot types, the geochemical plot types that are available in EnviroInsite. We'll have a quick peek at the data requirements, the data you need in EQuIS, and the licenses. And then we will move on to a demo of each of the different plot types. And at the end, I will do a recap and open it up for questions. So without further ado, let's go on. Oh, change the order. So for the requirements, the software requirements, we're going to be using EQuIS Professional version 6.6 connected to the Earthsoft Springfield data, EnviroInsite version 10.0.064, .NET Framework 4.6.2, and all the software I'm going to be using is 64-bit Office 365. So the data requirements in EQuIS are, we need analytical data with inorganic analytical results. So that's anions and cations. So I've got a little screenshot here showing the CAS numbers and equivalent weights of those CAS numbers. So these are things like calcium, sodium, potassium chloride, nitrate, and things like that. The equivalent weight is entered so that EnviroInsite can convert the analytical data from mass per volume units, so that's milligrams per litre, into equivalent charge concentration, so that's milliequivalents per litre. And this is stored in RT-analyte detail in the equivalent weight field. These are required to produce these plots, and for each parameter they can be calculated based on the atomic mass and the charge. The other thing you need is EQuIS and EnviroInsite licenses. So the type of plots that are available from EnviroInsite are stiff plots, and we'll look at those in a minute. And for stiff plots, they can be either georeferenced or static. Piper plots, and this is a screenshot of a Piper plot. Then we've got Schoeller diagrams and Durov diagrams. And so without further ado, I'll go on and show you those as we produce them. So this is the georeferenced stiff plot. So for the demonstration, I've already connected to an EQuIS database, and the first thing we're going to do is plot the georeferenced stiff diagrams. So I'm just going to persuade EQuIS to open. Oh. No, why is that not? I have EQuIS open in the background. Okay, let's go. So here's EnviroInsite. So I've already come to EnviroInsite and connected to the EQuIS database that you will have been shown how to do in one of the previous two office hour sessions. And I've already plotted my locations. And I know that was covered last week. So the first thing I'm going to do now is plot the georeferenced stiff diagram. So I'm going to come up here to the plot window, select 2D data, and come down here to select the stiff diagram. And it takes a few seconds for the dialog box to open. So the dialog box allows us on the first page to select our input parameters. So I'm going to tell them that I want to look at groundwater, and I'm going to enter the fraction wildcard. So it'll either bring back it'll bring back any fraction. If I knew my data was either all dissolved or all total, I could specify a single fraction, but for this demonstration, I'm going to enter the wildcard. I'm going to tell it just to bring back the first parameter, the first set of results, and then I'm going to subfilter on a certain set of locations. So for this instance, I'm going to come to list, and I'm just going to say, give me B42, B44, B45. So I'm just holding down the shift button and clicking on each of those, and then move them over to my selected side. Clicking OK. And then I'm just going to leave the rest of the parameters on this screen as they are. I'm now going to move and select the ions that I want to plot. So what EnviroInsite is doing is looking into the EQuIS database and finding analytes for which I've got results, and also which have details in RT analyte details. So anything with a negative equivalent weight is plotted, is available for selection in the anions, and anything with a positive equivalent weight is available for selection in the cations. So these are actually the parameters I want to use, but to select them, I just click the drop down and then scroll through and select the parameter, select the one parameter, and so forth. But this is set up exactly as I want it. I can then move to the options tab, and it will allow me to select color and various options for my plot. And on the labels tab, I'm just going to remove the post interval ID and tell it to put the location. So this would tell me what depth my screen interval is, whereas this, I'm just going to say, give me the borehole name. Then I'm just going to say, OK, and it will take just a few seconds, and here we go. So we've got the plots coming up here. They're not very big, so we can go and play with that in a second. What the first thing I'm going to do is turn the labels in my background plot off. So I've opened the locations up, and I'm going to say don't plot the labels so that we can see our stiff diagrams a bit better. So here are the stiff diagrams, and I can drag and move them around. Sorry, my mouse is got delayed by the meeting. There you go. Drag and drop them and move them around. And I can return back by double clicking on the stiff diagrams. It will reopen my input parameters. Okay, and I'm going to say, well, that showed me some nice information. So what I'm going to do this time is remove those, but this time I'm going to tell them, show me all of the wells that begin with B4. And I will probably want to make this my plots a little bit bigger. So why don't we make them 60/40? See what it does for that. And say, OK. Again, it's going to query the data. OK, there we go. It's plotted the stiff diagrams a bit bigger. And we can, as I said before, we can drag them around and show so you can see them a bit better. And this shows the patterns. So our magnesium equivalent concentration is plotted out on this axis, the calcium in the top, the calcium across the middle, sodium and potassium across the top. And you can see how the water changes chemistry, inorganic chemistry, as it goes through the site. Now, for some people, the ionic balance charge difference is important, and they would like to see which charges appear. And so this over here is got a filter, is saying which what charge balance is the maximum that should appear, so that if you have a poor analytical chemistry, you might want to say, don't show me anything with a charge imbalance greater than 5. So the charge imbalance is specified here, and I can just say filter by balance, and you get a little thing saying filter by balance error. And I can also tell it to say show the charge balance, and if I say apply, it will do some more calculations. It's querying the EQuIS database and plotting. And now you see that B42 disappeared because it was imbalanced. I turned the filter, I filtered that out. And here at the bottom, you have the percent balance shown. Okay. Now, as well as georeferenced stiff diagrams, you can also plot what I'll refer to as static stiff diagrams. So you could just have them appear on a page. The input parameters are exactly the same. And in the interest of time, I've just made that plot and shown you how they appear. So it's exactly the same data. I did exactly the same parameters as I've shown you just now, but I've already plotted them for us for all the B4 wells. Okay, then moving on, the next plot we're going to look at is the Piper diagram. So to plot the Piper diagram, I can come here and select from this menu on the task pane on the right, choose Piper diagram. And in a second, it will open up a new window. And again, very similar to what we saw for the stiff diagram. I'm going to select my same input parameters. So first, my media is groundwater, my fraction is percent. This time I'm going to apply the filter of B4. And that's all I'm going to do on the first page. And it's remembered the ions as I set them up from the stiff diagram. So exactly the same as I did before. I've got my anions at the top, bicarbonate, chloride and fluoride. My cations are sodium and potassium, calcium and magnesium. Now, the Piper diagram will end up with a plot like this, and this reference here, C1, tells you which axis that's going to be plotted on. So the C1 axis is here, and that the sodium and potassium results combined will be plotted reference to that axis. The calcium compared to the bottom of this, and the magnesium to that the C3 axis. And then the same for the anions. I will just go ahead and do that and show you, and then we'll come back and look at some other options. So again, it's querying the database, doing the calculations, and plotting the wells onto a Piper diagram. So here you go. As I said, we have the well locations here, and each of these individual symbols represents a particular location. And so from looking at this, you can tell that B4 has got a very different inorganic chemistry to most of the wells who are sat down in this area. And it looks like it's mainly due to our, what have we got? 80 calcium. Our calcium results are quite high compared to the rest of these ones. And so when the data from this graph and this graph are both projected onto the diamond, you see the chemistry of the wells plotted, and this can tell a story. I don't know what the story is at this well, but in some places you can see how the chemistry of the water becomes much more anaerobic as oxygen goes away. And it's a very good way you get a nice path like that. So let's go back to the input options and see what else. So I've just double clicked the Piper diagram, Now, quite an exciting feature is these total TDS circles. So I'm going to tell it to plot the TDS circles on. So this is going to plot a circle round each well symbol, showing you whether it's the size of the circle is proportional to the concentration of whichever constituent we select down here. So because it says TDS, I'm going to go ahead and plot total dissolved solids, and I'll click apply. Say okay. Oh. So now you can see that these circles are represent the total dissolved solids concentration, and this one to me looks a little bigger than some of these. So that's one thing. Now, another exciting functionality is that we can plot two different sets of wells on the same diagram. So what I could do here is right click where it said Piper diagram and tell it to duplicate. So it's giving me two sets of exactly the same data, so that's not much use. So let's go ahead and change one of these sets of data. So I've just double clicked on the header, and let's look at the B3 wells. And so we can see what's different. Let's change their color to something. Let's go with green for this. And green for its outline. And let's change the shape to a star. Let's make it a little bit bigger. Okay, and while we're looking at this, again, we've got the charge balance error that I showed you here. So you can filter out things with the ionic balance that you may wish to use. So let's plot that. Let's say, okay. So now you can see we've got some extra wells on here. We've got our green circles and green stars associated with the wells beginning with B3. And we've got our brown circles and brown diamonds associated with the wells beginning with B4. So the way you might use that is if you've maybe got two different aquifers, so a shallow and a deep, you would probably see very different patterns on here from the shallow and the deep, where the shallow is probably more aerobic than the deep aquifer. Okay, I'm just going to remove that last one I put on, and I'm going to edit this one to show you that you can just use one well with time series data. So in this instance, I'm going to go and say, show me all data. And this time I'm just going to say, use the well B4. So I removed the wildcard off the end. The B4 % sign meant use anything that begins with B4. Now I'm just going to tell it to just use B4, but show me all data. And I say okay to that. We've now got locations here, the same location. It's one well, but we had 3 different sampling periods. And I played with this data to make the chemistry change so that you can see with time, the water chemistry has changed. The magnesium concentrations have increased. And what did I change down here? Looks like I've changed the bicarbonate concentrations as well. So you get a nice line and you can see a progression. So you might see that kind of thing happening as you start pumping a well. So that's all I've got to say on the Piper diagrams at the moment. Some of the options are available in the little dialog box over here. So it saves you double clicking up here and opening the menu, you can come down here and change them. Like I can say, don't plot the label, apply, and it will do the edit for you there. So I've just got rid of the label by doing that. So let's move on to Schoeller diagrams. So I just came over to task pane, create a new window, Schoeller diagrams, and it's opened me up a dialog box. Now this time the query is slightly different because it's not just restricted to inorganic parameters. So all my data is available here. I'm just going to go and select my friendly B4 series wells. And from my parameters, let me go and get, what did we have? We had bicarbonate. Let's go and get some of our friendly parameters. Bicarbonate, chloride, we had some calcium, magnesium. Let's just stick to 4. I can select which fraction, filter on fraction here, and I can choose which axis of the plot I want to put it on. So let's put our cations and anions on different plots. On the line format, if I come to this tab, it allows me to choose select options for my colors for each of my wells. And I can come to the left axis and right axis, and let's say set default. And choose how I want to see the parameters there. So let's just say, okay, let's see what that gives me. So there you go, you get a plot with each of your wells as a different series, and in this instance, and each of your analytes as along the x-axis. I have the option here of turning on it's initially defaulted to have a logarithmic axis on both sides. So if I wanted to remove that, just double click up there, open this up, and I came to left axis and say remove the log scale. I can come to right axis, remove the log scale, and if you notice we had scientific notation there, but not on that side. So let's make both of them the same and say okay, and let's see what this is going to give me. So now you've got a graph that looks a little bit nicer, that shows us our shows us something's way out with B45, doesn't it, for magnesium? It compares the concentrations across that one diagram. Again, to edit the parameters, you just saw me double click on there and it opened up the dialog box. So moving on quickly to look at the Durov plot. Again, I've just come over here, selected Durov plot from the task pane, and it's going to open me a new window. You're going to get used to this now. I'm going to say my same parameters. Groundwater, let's choose the wildcard fraction and go for my favorite B4 wells. My ions, it's already remembered because we've been playing with them, so I can choose them from the down arrow here. And again, it's got the map, the key here that says C1, C2, C3, and so that relates to these parameters here. The A1, 2 and 3 relate to these parameters here. But now we've got 2 extra parameters, P1 and P2. Now they are selected from this Analytes tab, but there's also a shortcut from here to select. So if I go back to select ions, I clicked on there, but I could have easily just clicked on that tab. So from here, I'm going to go and choose, we looked at total dissolved solids earlier. So I'm going to choose that, and then I'm going to say set default. And what the interface is doing is querying EQuIS to find out what the minimum and maximum for this data set is, and then choosing itself an interval based on those parameters. And I think we've got some sulfate data as well. So I'm going to scroll down. These are in alphabetical order now. So sulfate, there you go. Let's set default. Again, it's queried and told me my maximum is 2,700. So why don't we set the interval to 500? Just because it's nice round numbers. We can choose to plot the labels again and the label sizes. And then we have our color options here as well. So let's make this a little bigger so that you can see it. And let's go say okay and see what it gives us. So we've got a similar thing to our Piper plot. I'll tell you what, I'm going to, just to make it easy, I'm going to turn these the location labels off. So I'm going to double click on the Durov diagram again and come to labels and say, yeah, let's get rid of the labels for now, just so that we can look and see what we've got. Okay, so now we've got our data here. So we've got our triangular diagrams that we saw from the Piper plot, and this time they're projected onto a square rather than onto a diamond. And now we can also project these against, I think we said total dissolve solids here, and also our sulfates from down the bottom. So tooltips, there it is. I've come up to the view menu and say I'm going to post tooltips. And so now when I hover over this, it's going to tell me what well it is, but when I disappear, it's gone. So that was under view tooltips. That's just a toggle on and off button. So if we look at this one, this is well B4, and project that onto the square, that's well B4, and I bet you any money that's well B4 as well. So this is using various different plots to project and study the relationship between various analytes. And again, like I did with the Piper, I could just do this for that one well, B4, and show the time-related data, or I could do it, I could also do it for you know, different colors for the B3 wells and different colors for the B4 wells. So a quick review of the steps. For each type of plot, I selected some query information. I selected what kind of sample I wanted, the matrix, the fraction, and then I selected whether I wanted all the data or just the first data, or in that dialog box there was also date data. I also selected which locations I wanted to plot. Then I went to the different tab and selected the ions or the analytes. I then went to the color tab and selected the colors and label options. And then I plotted it. And then I went and edited the color and label option and edited scales and things as I wanted to do. For the stiff plots, we could have, like I showed you on the Piper diagrams, we could have done B4 in one color, B3 in another. So we added georeferenced plots. We plotted from the plot menu right at the top. So if I just bring that up, the stiff plots we plotted from here, plot, from the map menu, plot, 2D data, stiff diagram. Whereas when we did the static diagram, we plotted it from this task pane here. We could change the colors for the different types of locations. We edited it to show the charge balance, so that number appeared at the bottom, and then we filtered out anything with a charge balance that was too high for us. And then I showed you in a pre-prepared static stiff plot. So for the Piper plots, we did all the initial input parameters, and then we added the total dissolved solid circles. we changed the colors for different locations. And then we also edited the parameters. So we just showed one location, but over different time period. For the Durov plots, again, we compared the ions. This allows us to compare our ions to our total dissolved solids and our sulfate. And we were able to edit scales. Oh, and that's a good job. I didn't show you the EQuiS Query window. So on here, if I come to the Durov diagram, and this has been available on each of the input parameters, there's this EQuiS Query tab. If I click on here, you can access some of the data, pre-filter some of the data that you wanted. So these are location groups. You can, do a pre-filter on the query to show only, say, the monic wells or a sample type, or certain tasks. And actually, if you've got a pre-saved PIC report from inside the EQuiS database, you can access that PIC report from here and then use that to apply it to the data, and then further filter that based on the query and all that other information. That's the end of the demo. Just wanted to say this is a third in the 4-part Explore EnviroInsite series, and the series runs through to next week, and it's included the cross sections, and I've included a link to the recording of that meeting. The base maps and layouts, I've included a link to that meeting, and this is today's, so there will be a link in there soon, and next week is strip logs.
Thank you so much, Jo, for presenting. This is really interesting. Thanks so much, everyone, for your attendance, and I hope to see you next week. Have a great day.